Hoje vou falar sobre os obstáculos à cura. Essa é a imagem de cada pessoa que interrompe o uso de antivirais. Sem considerar o tempo de supressão antiviral, o vírus irá aparecer logo quando o tratamento é interrompido. So obviously, the virus has discovered a way to persist in individuals in the face of overwhelming antiretroviral therapy. And when therapy is removed, the virus reappears with a vengeance. So what is considered the major obstacle to the cure? So cientistas, Doug Richman, Tony Fauci, Bob Silicano, demonstrated that virus lies latent in memory CD4 T cells. So células CD4 de memória conferem memória imunológica para que os patógenos encontrados na infância sejam rapidamente eliminados se encontrados na vida adulta. A habilidade do HIV de adquirir resistência nessas células leva à persistência do mesmo por longos períodos. Esse reservatório é considerado o único grande obstáculo para a cura da infecção por HIV. A grande questão é qual latente é o reservatório. So the scientists are showing that the virus is lying dormant in memory CD4 T cells that confer lifelong immunologic memory. Now, if that is true, the cure of HIV is going to be a formidable task, very difficult. Because the virus is invisible to the immune system, it's invisible to antiretroviral therapy. But the question is, how quiet or how latent is that reservoir? Is the virus truly completely dormant? Or is there something going on that distinguishes a latently infected cell from an uninfected cell? So in this image, here is a latently infected cell. Now, if one were to put an infected cell side by side, there are many differences. There is the provirus, there is viral RNA, viral proteins, and perhaps viral antigens on the cell surface that can serve as targets for CD8 T cell recognition. But if one puts this latently infected cell next to an uninfected cell, the only difference is that the infected cell contains a provirus. But there's nothing else within this cell to distinguish it from an uninfected cell. And if that is the case, it makes removal of this latently infected cell extremely challenging. So this year at CROI in Seattle, Mary Kearney, who works at the NCI Frederick, was examining a phenomenon called homeostatic proliferation. Alguns dos reservatórios em latência irão duplicar quando as células sofrem mitose. No entanto, não está claro se essa duplicação celular é importante contribuído para a persistência do vírus. When an infected cell, for example, a latently infected cell, is duplicated at mitosis, each daughter cell contains a provirus. So now you have two infected cells. Some of those daughter cells may die in the normal process of homeostasis, but some are continually undergoing division. And a number of laboratories have shown that these duplicated proviruses actually eventually dominate the viral population. In some individuals, as many as 30% of the viral genomes are identical. They have identical integration sites. So they arose from a single integration in a cell that underwent repeated rounds of mitosis. So what Mary Kearney demonstrated is that at any point in time, 5% of expanded proviruses are transcriptionally active. Now, it's likely that those proviruses are cleared, cytopathic effects of the virus or immune clearance, but a steady state is maintained through homeostatic proliferation. So those cells that die are replaced by more clonal outgrowths of those proviruses through homeostatic proliferation. A implicação é que o reservatório é dinâmico, portanto, pode ser vulnerável à eliminação por imunidade antiviral. This is a very important point, because if this is correct, it means that it will be possible to distinguish at least a large percentage of the latently infected cell population because they are expressing something. They're transcriptionally active and quite possibly making viral protein and viruses. Then there is a less popular model that proposes reservatório ativo, an active reservoir, one that might support continued virus production, and those produced viruses go on to infect other cells, even in the face of antiretroviral therapy. So, alguns estudos têm sugerido que os reservatórios virais podem estar ativos e que o vírus possa ser capaz de replicar até mesmo na presença do antivirais. Esse tópico é bastante controverso. So it proposes that there may be cells, perhaps these homeostatically expanded clones, manufacturing virus, and that even in the face of therapy, some of that virus can infect new cells. So this is considered to be an active reservoir, as opposed to a reservoir in which the virus is retained in a latent state. O Dr. Shacker e Haas descobriram que a concentração de alguns antivirais, mas não todos, na droga é menor nos tecidos do que no sangue. Isso tem sido difícil para alguns pesquisadores aceitarem. Se o vírus não é completamente inibido, a previsão é que deve haver evolução da sequência e resistência aos medicamentos. No entanto, estudo de Steve Walensky e colegas indicam que é possível ter baixo nível de replicação sem acompanhamento, evolução e resistência. So one possible theory is that antiviral concentrations in lymphoid tissue, lymph node, ileum, and rectum, as shown in this study by Ashley Haas and Tim Shacker, is that concentrations of antivirals aren't always at levels sufficient to completely shut down de novo infection. But again, when people think of ongoing replication, they think of repeated rounds of viral spread. Virus is produced from a cell, it goes on to infect another cell, which produces virus and repeats the process over and over. And I think there is some misconception and misunderstanding in the field. Because all the data that's been published so far does not show that there are multiple rounds of replication, but can be explained by a reservoir that makes virus, and that virus goes on to infect other cells in a single round. That does not involve rounds of replication, and therefore one would not expect sequence evolution or accompanying resistance. But at the same time, it does have the capacity to infect new cells. And I think with this model, one can reconcile the different opinions of researchers in this area. Há algum reservatório ativo ou marcadores que poderiam informar a dinâmica desse reservatório e a sua contribuição para a persistência viral. Vou falar sobre RNA cell-associated RNA. Há quase 20 anos, o Dr. Walensky, que trabalha na Northwestern University, Chicago, demonstrou que os linfocitos CD4 contêm RNA viral em indivíduos em uso de arte. Mesmo agora, o significado dessas observações não foi claro. So almost 20 years ago, Steve Walensky observed that in individuals on antiretroviral therapy, some of the CD4 lymphocytes contained viral RNA. Again, reverberating the theme that the reservoir, at least some part of it, may be more dynamic and more active than one would expect from a totally latent reservoir. But it's unclear what the significance of those observations might have been. So Jonathan Lee is a scientist at Mass General Hospital in Boston. Dr. Lee mediu a quantidade de RNA viral associado à célula em indivíduos que interromperam a terapia. Ele então mediu o quão rápido os vírus reapareceram. Dr. Lee encontrou que o vírus reaparece mais rápido em pacientes com elevados níveis de RNA associado à célula. So what Dr. Lee did is he measured the interval with which virus rebounded when treatment was stopped. If treatment was stopped in 4 weeks, if the virus rebounded 4 weeks after treatment was stopped, 5 to 8 weeks or 7 weeks, he found that there was a significant relationship with the level of cell-associated RNA at baseline. So if there is more cell-associated RNA at baseline before the individual stops therapy, there is more likely for the virus to rebound faster. So the implication is that this active viral reservoir is biologically significant because the amount of cell-associated RNA predicts how quickly someone will rebound if they stop taking treatment. But an assumption in this study is that the time to viral rebound is an indicator of viral reservoir size, and that's still something that has to be validated. So, o tamanho de reservatório está associado com o tempo de reaparecimento do vírus. Níveis significantemente reduzidos de cell-associated RNA em indivíduos tratados durante a infecção aguda. So individuals who go on treatment early, they have less cell-associated RNA, presumably smaller reservoir size. Sugerem que células infectadas podem ser reconhecidas pelo sistema imune. Portanto, melhorando a imunidade antiviral pode ajudar na eliminação dos reservatórios virais. So the implication is that if indeed this reservoir is making something that can be recognized by the immune system, it provides the rationale for immune-based therapies that heighten the ability of the immune system to recognize and kill infected cells, perhaps aiding in elimination of the reservoirs. So I now turn my attention to a controversial topic, one that my lab has been wrestling with for a number of years. Poderão os reservatórios de macrófagos, desculpa, mantém o HIV em fase da arte. Could macrophage reservoirs sustain HIV in the face of suppressive antiretroviral therapy? Pesquisadores tentaram purificar macrófagos de tecido de indivíduos infectados. Essas experiências são desafiadoras. Alguns tecidos não podem ser acessados em indivíduos vivos, por exemplo, CNS, Central Nervous System. Também a presença de vírus, DNA, em macrófagos purificados não é suficiente para demonstrar reservatório. So some individuals have shown that macrophages purified from infected monkeys can phagocytose infected T cells, thereby acquiring viral DNA. But that does not prove that those macrophages were directly infected. So this has complicated efforts to show the presence of a macrophage reservoir in infected individuals. And in addition, the most likely place to look for infected macrophages is in the brain, but that is it's impossible to access in living subjects, and it's notoriously problematic for reservoir studies in post-mortem tissue. O envelope do HIV primeiro contacta CD4 na superfície celular. Isto permite a interação com CCR5 e fusão entre o vírus e a célula. Os macrófagos têm níveis muito baixos de CD4. Por conseguinte, as alterações no envelope viral permitem ao vírus interagir eficientemente com as moléculas de CD4 para poderem infectar macrófagos. So this is the events involved in the interaction of the virus with the cell surface. The viral envelope binds to CD4, and that triggers a series of events involving subsequent binding to CCR5 and then fusion of viral with cellular membranes. But macrophages have very low levels of CD4, and as a consequence, the virus has to be able to engage CD4 very efficiently in order to achieve interaction with the macrophage cell surface. So the primary determinant for macrophage tropism is actually the ability of the virus to efficiently use CD4. A capacidade do HIV de infectar o macrófago é determinado pela eficiência com que o envelope viral pode utilizar os baixos níveis de CD4 que estão presentes na membrana dos macrófagos. A existência de reservatório de macrófagos pode ser inferida pela presença de envelopes que utilizam eficientemente CD4. Estes envelopes aparecem na varímia de rebote quando a arte é interrompida. So if viruses originate from a macrophage reservoir in individuals that interrupt therapy, one would predict that the rebounding viral RNA is populated by viruses with envelopes that efficiently use CD4. So when art is interrupted, quando a arte é interrompida, os vírus emergem dos reservatórios celulares. Se os macrófagos formam parte desse reservatório, é possível que algum do vírus tenha uma elevada afinidade para CD4. Portanto, avaliamos que o vírus para a presença de envelopes que tinham tropismo para macrófagos. So we obtained recrudescing viral RNA from individuals who underwent treatment interruption. We then looked at the composition of this virus to ask whether that virus contained any isolates that may have evidence of macrophage tropism. Uma possível desvantagem desta abordagem é que os vírus com tropismo de macrófagos podem ser ultrapassados pela replicação viral em linfocitos CD4. The problem with this experimental approach is that when there is explosive viral outgrowth after treatment interruption, most of this outgrowth is going to occur in CD4 lymphocytes, which would mean that any macrophage tropic viruses present here would rapidly be overtaken in quantity by explosive outgrowth of the virus in CD4 T cells, viruses that would not have macrophage tropism, but T cell tropism. Nevertheless, we went ahead with the study. So, RNA viral isolado da viremia post-analytic treatment interruption, ATI. Os envelopes virais foram obtidos por single genome amplification. Envelopes utilizados para construir clones moleculares infecciosos recombinantes. Competência de replicação confirmada em células TZM-BL. Tropismo de vírus recombinantes avaliados. Fusionacidade para macrófagos. Infecciosidade por PCR. E replicação em macrófagos. So the procedure is to obtain viral envelopes from recrudescing viral RNA, clone them by single genome amplification, and then construct recombinant infectious clones with these SGA envelopes, confirm that these recombinant clones are replication competent, and then look at the property of these recombinant viruses on their ability to infect macrophages by PCR, their ability to replicate within macrophages, and their ability to fuse with macrophages. Este gráfico mostra a capacidade dos vírus recombinantes para infectar macrófagos. A maioria dos vírus não infectou macrófagos, mas alguns destacados aqui infectaram macrófagos. Os níveis eram comparáveis às estirpes de vírus com tropismo eficiente para macrófagos. So in this population of individual viral recombinants, some small number of individual recombinants appeared to have the ability to infect macrophages at levels at least comparable with these viruses, which are highly macrophage tropic recombinant viruses that have been described in the literature. This is a T-cell tropic virus that does not replicate within macrophages. So we took these viruses for further study. Nós examinamos se esses vírus foram capazes de ser fundir com macrófagos. Usamos assay descrito por Warner Green, uma enzima é impactada no vírus, o substrato da enzima, CCF2, adicionada aos macrófagos, se a fusion ocorre, a enzima irá converter CCF2 de verde para azul. Nestas imagens, não há células azuis em macrófagos infectados com vírus T-trópico. Existem muitas células azuis em macrófagos infectadas com o vírus macrófage trópico. E também em macrófagos infectados com vírus recombinantes de pacientes com analytic treatment interruption. So the assay uses a strategy described by Warner Green, where beta-lactamase is packaged within viral particles because it's fused to VPR. We then incubate the macrophages with a dye called CCF2, which is taken up. If this virus is then able to fuse with macrophages, because it uses CD4 efficiently, then the CCF2 will be converted by enzymatic action from a green fluorescence profile to a blue fluorescence profile. So this here is a profile of cells infected with a virus that does not even have an envelope. So one only sees green cells. This is a T-Trels tropic virus, 4013T, that does not infect macrophages. Again, one only sees green cells. Here we have a virus that's highly macrophage tropic, and we see lots of blue cells in this field. If we then take some of these recombinant envelopes obtained from individuals during treatment interruption, we see lots of blue cells, indicating that they have the capacity to infect macrophages. If we then look quantitatively, so esta imagem mostra a quantidade de células azuis em macrófagos infectados com vírus recombinantes. T e M-tropic vírus são facilmente distinguidos. So here is a numerical representation of those fields. So T-tropic viruses lack the ability to fuse, so there are no blue cells in the field. These macrophage tropic viruses fuse efficiently, so we have lots of blue cells, so it's clear, it's easy to distinguish the phenotype of the viruses with this assay. If we then look at these recombinant viruses from these patients from the recrudescing viremia post-ATI, we see that these envelopes fuse efficiently with macrophages at levels approximating what we see for macrophage tropic viruses. So, o teste mais robusto para o tropismo de macrófagos é a capacidade de replicar dentro de macrófagos. Em seguida, avaliamos se esses vírus recombinantes realmente replicavam em macrófagos. So the most robust test for replication for macrophage tropism is the ability of the envelope to confer replicative spread on the virus in primary macrophages. Nesta imagem, comparamos a capacidade de replicação dos vírus M e T-tropic em macrófagos. Existe uma clara separação entre os víruses. So here we're comparing the control viruses. These are T-cell tropic. They do not replicate within macrophages. And here we have these macrophage tropic recombinant viruses that have been well described in the literature. Quando incluímos os resultados com os vírus recombinantes, é evidente que estes vírus têm a capacidade de replicar efficientemente em macrófagos. So if we now take these patient-derived envelopes, we see that they confer the capacity of these recombinant viruses to replicate efficiently in macrophages at levels comparable to or exceeding these highly macrophage-tropic recombinant viruses. Quais são as relações filogenéticas entre os vírus M-tropic e T-tropic emergence após analytic treatment interruption. Esta análise filogenética demonstra que o vírus se separa de acordo com o tropismo, sugerindo que eles se originam de reservatórios celulares distintos. So the macrophage tropic viruses segregate over here and are easily distinguishable phylogenetically from the viruses that did not infect macrophages, suggesting that these macrophage tropic viruses and T-cell tropic viruses in these individuals originate from different cellular reservoirs. Dan Kuriskas investigou por que o paciente de Berlim foi curado. Já falei sobre isto ontem. Talvez a quimioterapia usada para eliminar as células do sistema imune foi responsável. Ele fez uma transplante de medula óssea de doador com células normais para CCR5. So Dan Kuriskas wanted to try and get some insight into why the Berlin patient was cured by a CCR5 homozygous deleted bone marrow transplant. So he used low-intensity conditioning and allogeneic stem cell transplantation with cells that had wild-type CCR5 alleles. So 2 individuals went through this procedure. This is patient B. Apesar da quantidade de vírus DNA viral indetectáveis, o vírus retornou quase após 10 meses. Após tratamento foi interrompido. So when treatment was interrupted, there was no recrudescence of the virus until around 10 months later, when there was this spike and renewed viremia. Sugere que a presença das células tronco CCR5 null é necessária para a cura, no contexto do transplante de medula óssea. Mas ainda obscuro de onde o vírus originou. Uma vez que as células T CD4 foram completamente substituídas pelas células do doador. So where did this virus rebound from? Because presumably there was complete chimerism. All of the recipient's CD4 T cells had been replaced with the CD4 T cells from the donor that were originated from the stem cell transplant. So isolamos envelopes do vírus plasmático deste indivíduo e determinamos sua capacidade de infectar macrófagos. So we obtained viral envelopes from this individual when the virus recrudesced. We cloned those envelopes by SGA, and then we examined the phenotype of those envelopes using the same approach that I already described. So here is a collection of envelopes from this individual, and here are the macrophage tropic viruses, and here are T-cell tropic viruses. Podemos observar que alguns desses envelopes tinham tropismo de macrófagos. So some of those viral envelopes appeared to have relatively high levels of fusogenic capacity for primary macrophages. Em seguida, confirmamos que esses envelopes mostrados em verde, derivados do paciente de Boston, conferiam a capacidade de replicar em macrófagos. So as shown here, these virus profiles in green Those envelopes obtained from the Boston patient appear to confer the capacity to replicate within macrophages at levels approximating those with these highly macrophage-tropic viruses. T-cell tropic viruses are shown in the bottom here. So, os macrófagos alimentam a recrudescência viral em indivíduos suprimidos de arte submetidos a analytic treatment interruption. Qual é a fonte e longevidade dessa fonte? Indicar, mas não provar, a existência de reservatório de macrófagos em indivíduos. As estratégias para a eliminação de reservatórios podem necessitar ser distintas das utilizadas para purgar reservatórios de células CD4. So the take-home message is this suggests that a macrophage reservoir exists in the face of antiretroviral therapy and contributes to treatment, to viral recrudescence when treatment is interrupted. Suggesting that we may have to adopt unique strategies for the elimination of this reservoir if we're ultimately to achieve a viral cure in infected individuals. Quero agradecer o trabalho de Viviane Machado aqui. Brasileira, ótimo, legal. Fabuloso estudante de doutorado brasileiro, bem como Thaisa Cordeiro, técnico do laboratório, também do Brasil. Elas são pessoas maravilhosas para trabalhar. E também brasileiros não merecem brasileiras. Verdade? Eu também quero anunciar uma conferência em Miami que vai se concentrar na pesquisa de cura do HIV. Miami é lugar maravilhoso para visitar em dezembro. O único problema é você correr o risco de ver Dr. Watkins ou Desrosiers em seus speedos. Obrigado pela sua atenção.